example 1. So what I'm going to draw now should constitute example 1. So I am drawing something.
Example 1 is going to be classwork, right? Like going forward?
Yes, it's part of classwork. Yes. So document everything we are doing. Yeah, it's part of classwork. Okay, so I am going to use part of the very variables that I used before. So this side is going to be x plus 2. So this side is x plus 2. And then this side is 5x minus 3. And then this side is you can say this side can be x plus 1. So now here's the question. The question is determine the volume. What's the name of this shape that I just drew?
Rectangular prism.
Rectangular prism. So determine the volume of the rectangular, rectangular prism. Okay, so that's our example number 1 task. And I'll give you 3 minutes to give it a try. So the time now is 8:57. So you have 3 minutes to give it a try. Always start by writing your formula if something has a formula. If it doesn't have a formula and it has a theorem, also write the theorem that you are going to use or you are going to apply. You got 2 more minutes. 1 more minute. Okay, so now let's give it a try. So first of all, what's the formula that you need?
Volume equals length times width times height.
Okay, thank you. Somebody gave us a formula, and let's say our solution, and then we start with volume is equal to length times width times height. So everybody agrees with that? Yes. Okay, so what's next?
Plug in the values.
Okay, you plug in the values. So the length is 5x minus 3, and then the width is
X plus 2.
X plus 2, and then the height is
X plus 1.
X plus 1. Okay, so you see, I made this thing to be a little easy. So we already did, when you look at 5x minus 3 and x plus 2, when you multiply it, that should give us this number here. Is it not true? You want us to repeat the process?
No, it gives us the same thing.
Yeah, so it should give you the same thing. So I mean, the process should be in your paper, so I don't need to repeat it. So we can just say that the first one, this one, gives us 5x squared and what? Plus 7x minus 6. That's this one. And then we are multiplying it by x plus 1. Okay? So at this point, we also use distributive property. You agree? Do you agree with that?
Yes.
All right. So now, always start. I mean, it is easier to start with the number that has the smallest term. In this case, this side has 3 terms. This one has 2 terms. So it is recommended that you start with the one that has the smallest term. So now let's say x multiplied by 5x gives us what? 5x squared rather.
5x cubed.
5x cubed.
Yes, 5x cubed. Then we repeat the process. X multiplied by plus 7x.
7x squared.
7x squared. And then we repeat the process. X multiplied by negative 6.
Negative 6x.
Negative 6x. Then we repeat the process. Then 1 multiplied by 5x squared.
5x squared.
So
yeah,
5x squared. 1 multiplied by 7x.
7x squared.
Plus, is it 7x or 7x squared?
7x.
7x. and then 1 multiplied by -6. You see, and you have -6. You see how I arranged it? The way I arranged, the reason why I arranged it this way is like it helps make combining the terms easier. I could write it the other way, but I decided to write it this way. So you just draw a line, and then this term that is a 0 here, so you just say 0 plus 5x cubed, you just write 5x cubed, and then when you add up 7 plus 5 gives us 12x squared, and then plus 7x minus 6x gives us what?
X. Plus X.
Yes, positive x, and then you have -6, and then this is our volume. This is our volume. You see the way it is arranged. Now, if you are looking at the exponents, now you see how the exponent in x is 1, is actually 1. The exponent in 6x, this 1, what would be the exponent of x here? The exponent is actually, okay, let me write this. 6 is 7 saying 6x raised to power 0. Do you agree with that?
Mm-hmm.
Because any number raised to power 0 is 1. Any number raised to power 0 is 1. So we can write this as x raised to power 0 here if we want to. But if we don't, there's no problem. It's the same. All right? So now this takes us to the definition of polynomial. You see? Now, instead of having, when we did area, we just had, when we did area, we had, what was the area again? Here. When we did area, what type of equation is this? Look at where I'm pointing right now. What type of equation is this? It starts with Q.
Quadratic.
Yes, quadratic equation. You see, when you do the area, especially given the size that are given to us, so we had a quadratic equation, and the highest power is 2. Now, when we do volume, we have, instead of having a quadratic, we have what is called trinomial. The highest value of the exponent is 3. Now, there are situations where the exponent, the highest exponent is going to be more than 3. It can be 4, it can be 5, it can be 6. It can be any other number in terms of exponent. So here, exponent, the highest exponent of x variable is 3, followed by 2, followed by 1, followed by 6. So now, this takes us to the definition of basically polynomial, or standard form of a polynomial. As a matter of fact, a polynomial is any equation that has more than, the exponent is more than 1. The highest exponent is more than 1. That's a polynomial. So quadratic equation is actually a polynomial. It's just that it has the highest exponent of x to be 2. A trinomial is a polynomial that has the highest exponent of to be 3. So there are other polynomials. So we can say that the standard form of a polynomial, is that you start with the leading coefficient. So this one, which is the highest one, is called the leading coefficient. So this is the leading coefficient, followed by the one that is following it, followed by the one. So you keep writing like that. But now let me write a polynomial, and then we try to write it in a standard form. So I'm going to write a polynomial now. So polynomials